Imagine we want to block, for example, a specific remote application, remote desktop application, TeamViewer, and so on. We can handle those behaviors by using the policies, the Allowlist and the Blocklist. So by using the Allowlist, we are basically telling to the system this is something legit, because probably even if it's not the top of the standard, to create a macro that spawns an executable, this is from an internal process, and we want it allowed. So I don't want to be notified. So suppression of the alert, and in presence of a protection, if this process is blocked, allow it. So by creating an Allowlist policy, we will be able to silence this sort of false positive. With the Blocklist, we are doing the contrary. So we are actually blocking the binary from being, the malware from being executed. So we discover that is something malicious or something that we don't want to have running. We can create, and this is and we just want to block this specific behavior. So wingward spawning tryme.exe, we can create a block list. The protection is the third type of policy. We have the list of the policies there, and it's a precompiled list. When enabled, for example, by using the ransomware behavior protection, every alerts identified as ransomware behavior will be blocked. And we have also, other than the alerts itself, indications about when the latest time this policy triggered. So last time the triggered was 1 month ago for this machine. Destra, just as a refresher, means detection strategy, and is the possibility through Lua scripting to write your own detection rules. I just want to give you an idea of how a Destra is made. Let me take. Okay. We have the possibility, in general, to apply the policies, including the Destras and every operation, isolated per specific client. So a client is a collection of endpoints of machine. We can handle it in a multi-tenanted fashion. So we can enable this Destra, the bits admin Destra, for example, for one or more specific tenants, or globally. So we can always have a granularity of the granularity degree of the operation that we perform. In this case, this Destra and the Destra are based on Lua is going to trigger when bits admin, which is a legit component, is being abused. Because an important element to remember, and that is facilitated through the behavioral detection approach, is that we can identify and investigate even applications that are abused. Because if, for example, I leave a TeamViewer, an AnyDesk instance up and running, or I deploy without notifying the user a remote control application, and then I use it from home, I'm basically using them as a vector. So sometimes, except the the malware that is known to be malware because it's already known. There could be application that are abused for malicious purposes. So alleged application can be a malware. This is an example. This is an example of how to leverage alleged component of Windows that is bitsadmin. Bitsadmin is the responsible for downloading and executing the Windows updates for malicious purposes. What we did there is to model the malicious behavior when a detection should trigger in presence of an abuse of bitsadmin. And the logic of the codes is on those 4 lines. In the first one, we are going to check if we are dealing with the real bitsadmin. So the original file name is bitsadmin and is signed by Microsoft. Then let's say the second check that we do is on the privilege level. Normally, bitsadmin runs with system privileges. In this case, the privilege level is medium, and this in general is an interesting point to keep in mind, because those elements, those evaluation elements, those attributes are runtime attributes, are attributes of the process itself, not of the binary. Destra can be also used not only by leveraging those elements, but also to deliver error rules. Important to say that there is an exception on this, that is, the error rule, the error scan, will trigger when the binary is dropped, so we have an event of executable dropped, or when is executed, is not going to perform a file system scan. So back to the Destra, we are now checking the privilege level. The privilege level is medium, and then we check the command line. What are the parameters used for bitsadmin? Download and transfer. Download and transfer are exactly the parameters used to download a binary, download an update, and execute it. This bitsadmin, which is signed by Microsoft, so can be abused to download and execute malware. The first anomaly is running as a medium, typically runs as system, as we said. Another suspicion element is the command line. The command line matches the download and execute behavior. Finally, we have the parent process. So who executed bitsadmin? Bitsadmin, given that it's a system component, is normally executed by services.exe. In this case, it's the attacker manually invoking bitsadmin. So the parent process of bitsadmin is one of the execution engine, of the standard execution engine on Windows. Command.exe, PowerShell, WScript, Cscript. So the anomaly that we have at the end is bitsadmin is running with medium privileges, is using those 2 parameters, plus is the child process of something executed manually by, for example, by using command.exe, PowerShell, and so on. So these, all those elements, when are verified, are going to trigger an alert. So we have the create alert. So this behavior has been purely modeled by observing and applying this Lua script every time a process is executed. Indeed, the Destra has a binding to process created. So for every process created, run this run this script.